everyone. Today I will first explain the full model logics of our project, and then deeply discuss the aspects, how I improve the model performance, how I assess and improve model fit, and how could I do to further improve my classifier. And this tactic is a binary classification problem evaluated using ROC and AUC. So my pipeline follow a structured process. First one is the data expropriations and also feature engineering, handling the imbalance and selected the to have model selections, and also have the cost validation, evaluation, bias variant diagnose, threshold turning, and example optimization. Each step was designed not only to improve the performance, but also to diagnose the model behavior. What I do to improve our performance? First of all, I have used some I begin with base 9 models that base 9 model, logic regression and decision tree, and logic regressions achieve all at AUC is approximately to 0.76. Also for decision tree is approximately 0.72. This indicated predictive signal in the data, but the linear assumption limit the performance. And also for the decision tree, a single signal tree precision data aggressively, leading to a higher variance and unstable F1 score field. For this comparison, I conduct that problem contains nonlinear interactions and feature combinations that the linear model cannot fully capture. Therefore, I moved to boosting model. Like for the boosting model, I have using the light GBM and improve OOC to 0.78 and improved F1 score as well. Also for the capped boost, further improved the AUC to about 0.8.02 with stronger record performance. They demonstrated reduced bias due to the boosting ability to model compressed the nonlinear structure. Cabos perform slightly better, like because it handled category variables more effectively and reduced the target leakage risks in category coding. To address class imbalance, since the positive rate is only the 11.7%, 11.7%, I use a stratified sampling and class weighting in boosting models. And I have used it in a lot of the ways, like the cost validations. I have split it into five folds. And also, I have by turning the threshold based on the precision record train off, and I put one F1 score better balance between the rejecting groups customer and proof weak swaps. So in the future engineering, I have also played a critical role. For example, I have trained the specific transfer the special value 1 paydays F-1 into a meaningful binary feature X first contrast. This reduces the noise and increases the interpretability. It also have great financial pressures and is balance, which combine economic ego and this in engineering feature increase effective model capability without increasing capacity. Also, I have implied some hyperparameter training, including learning weight and tree depth. In this way, I have tree depth and regulation strength. This have helped me to invested early stopping after training, where I usually have proved slightly and variance across for decrease, indicating a better stability. And what I do to assess input model fit, to properly assess model fit, I have used a certified cost for, as I mentioned, since is imbalanced. And also I have used my our model, our whole model at the same time in the last model that to analyze it, I use the model and combined with the light GB boost and cat boost. And in this way, she has appeared to uh, appearance that for the light boost, the train AUC is 0.8 and 0.78. And also for the cat boost, the train AUC is 0.8 and validation AUC is 0.8. And this gap indicates that mild overfitting, especially for the cat boost. However, the gap is not extreme, which means that the model is not memorizing noise. Also, I think learning curve for this model and the train score was significantly higher than the validation score, but the gap nowhere is training size increase, such as a mild variance, but no serial overfitting. This indicated that the model is reasonably well fitted and could possibly benefit from more data. To further interpret performance, analyze a confusion metric and position recall curve in a low approved setting. Also, by examining the precision curve adjusting the threshold, I set a balance between the default weeks while maintaining reasonable approved weight. Also, to control the overfitting, I have applied the stop regulation and limit tree depth and control the learning curve. And this technique reduces more model variance and improve the generations. And how if I have more time, what I could do? If I have more time, I could incorporate external data sets such as the microeconomic indicator or credit bureau information to capture broader financial weak signals. In productions, I could implement continuous monitoring of AUC F1 and proof of weight, and I could also monitor feature distribution shifts to detect data drift. If significant drift occurs, I could trigger the replication to return the maintained stability.